able and took the time to visit the commercial exhibition. The commercial exhibition is open at any moment. If you wish, you can stop viewing a presentation and go ahead and visit the commercial exhibition. Also, in the commercial exhibition, you're gonna see an icon at the left-hand side of your screen. You're gonna find the map. If you click on that map, you can select, you're gonna see all the sponsors, and just by clicking on their logo, you're gonna be directed automatically into that company. Okay, so moving ahead with the program for today, the next presentation is about new concepts and technologies for managing blueberries in soilless and substrate production. We are going to have Sebastián Ochoa and Mariusz Padewski, with Fernando Martino as the moderator for this second presentation of the day. So let's go ahead with this second presentation. Hope you enjoy it.
To the blog titled New Concepts and Technologies for Managing Blueberries in Soilless and Substrate Production. A brief introduction to the topic. This topic, to my understanding and to the audience for sure, is hugely important for several reasons. Some of them is the increasing competition among countries and within countries for global markets, a definitely more demanding and sophisticated global consumer, and of course, tighter margins for the business. And in this context, technology becomes a key driver to remain competitive, and for enlarging, of course, the competitive edge. This is part of the context within which our speakers will share some of their knowledge and experience with us. Today, we will be joined by Sebastián Ochoa. Sebastián studied agriculture and engineer. He also holds an MBA. He's an advisor and consultant to growers and exporters in several countries such as Chile, Peru, Colombia, Ecuador, Mexico, the US, Zambia, South Africa, China, and New Zealand. In conventional organic and biodynamic production, and as well as in soil and hydroponic conditions. He also has a lot of experience in projects of new genetics in several countries. Mariusz Padewski also joins us today. Mariusz has worked with European growers for more than 17 years. He also managed farms in the UK for several years. He advised growers interpreting lab results necessary for fertigation and fertilization corrections with an emphasis on proper plant management, specialized in substrate production. For the last 3 years, Mariusz has been associated with Volkriek Europe to advise growers on how to properly run blueberry plantations in Europe, Asia, North Africa, and the Far East. Before starting, Sebastián, with your first presentation, I will let you know how will be the structure and dynamics of this block. We will have first around 15 minutes presentation from Sebastián. Then Mariusz will make some questions for Sebastián. Then Mariusz will go ahead with his presentation. Sebastián will ask Mariusz some technical questions about the presentation. And then we will be back with Sebastián. After Sebastián's presentation, there will be a round of questions and answers from the audience. That's the way it will work. So having said that, please, Sebastián, you can go ahead with your presentation.
Thank you very much, Fernando. Good day, good afternoon all. First of all, I want to thank for the invitation to all of the ABO team, especially Kurt Brasselton, Luis Miguel Vegas, and Gaston Ciganda. Hello, Mariusz. Good to see you again. And well, this, like Fernando said, this item of the production is very, very important, and especially now because we can see this system in all of the countries that produce blueberries. So, and this is very important not for only blueberries, also for a long number of species, because I saw, for example, trees large trees like cherries, avocados in this system. The interesting things about this system is that it solves the problem of the soil, where we look for climate and weather, and water. And if the water is a limitation, you can use a correction with amendments, for example, the pH or relation within the cations, or we can use osmosis. So this is a big solution for the soil problem when we don't have soil finally. What is the base of the hydroponic system? This is a broadest conception. Encompasses any system to which plant complete their vegetative cycle without the use of soil. And we provide a water solution with all of the mineral nutrition complete with the different essential nutrition for development of the plant. And this needs a high experience. We need a high technical management and good quality of equipment to have a success in this system. So we can see that in a lot of countries. This is Peru, for example. Peru have sand, a lot of sand, but the problem with the sand is the fine part of the sand, and the roots of the blueberries need a lot of air. So we can make a solution of this problem with the system. This is in Chile. We can see the system. I started working with the system in 2005 or 2004 in the north of Chile. I will speak about that later, but we can see this system with a good quality substrate, good quality pots and irrigation system, good fruit. This is in Colombia, Mexico, South Africa, Australia, China. So finally, in every part of the world that we produce blueberries, you can see or you can use the soilless production, the production of substrate. At the beginning, the cultivation of the blueberries and substrate used a mixture of different materials, fragile materials, for example, sawdust, pine bark, soil, compost. And the problem with this system, when I started with that, you have a decomposition in the bottom of the bag. And this decomposition form alcohol, form a toxic composite, and kill all of the roots. And finally, you have at the beginning, at the top of the bag, you have all of the biggest part of the substrate, and without a good retention of water, and then the middle, you have maybe a good substrate, but at the bottom you have mud, and it's very toxic for the roots, and we cannot have a good drainage, and the plants at the beginning during 3 or 4 years and then die, and you can use 50 liters of bags, but finally you use the third part. And then the industry start to use this kind of material with the long fibers. The long fibers are water repellent and for compact balls that don't allow water and roots to enter the interior, generating a high water consumption because the large number of irrigation pulses that must be given for the water to penetrate inside. The other situation, in all of the new countries, they started with the substrate. I saw this, the rice husk. It's a very, very, very bad substrate because we don't have thermal inertia, it's repellent to the water, change the composition and the time, and it's a very bad substrate, and the substrates cannot hold the plant too. So with the substrate, with the move. Okay. And the substrate with the long coconut fiber needs 8 to 12 pulses per day to maintain the humidity versus a good substrate like the right you can see is a mix with a perlite cocoa fiber of good quality cocoa fiber and peat moss. And you can have a good drainage and good retention of water. And finally, what characteristics should have a good substrate of soilless cultivation? If I choose a substrate without one of these characteristics, this substrate is not a good substrate. Okay, this is a list. This was made from a book from a soil chemistry specialist in a hydroponic system. So we need a capacity to retain an adequate volume of water, the nutrient solution at a low voltages. That means easily available for the plant. Provide enough oxygen to cover the demand of the roots under any circumstances, in balance with the moisture retention, obviously. Be an adequate support of the plant, being durable over time, and that doesn't vary its physical and chemical composition, that doesn't interfere in the nutrition solution that we give to the crop. High thermal inertia, that means which allow the substrate doesn't heat or cool violently, having a high SIC, cation exchange capacity, allow having a degree of buffering power against errors in fertilization, and having a high C carbon and nitrogen ratio, because give us a very durable over time, more than 60 or 70. Okay. And in this evolution, in the setup of the material takes us to the current situation. We prefer use a product that's on more or less coarse grains, on 5 to 3 millimeters coarse or grainy coconut. And we use a very low percentage of fine dust and long fibers. The fine dust is decomposed very, very quickly, and the long fiber, the problem is the retention of the water. So you can see a good quality cocoa fiber works very, very well, and we can use peat moss with perlite too, but the problem is it's more expensive. And the advantage of this substrate has a high cation exchange capacity, is very important for establishing the regime of irrigation, fertigation, allowing intermittent fertigation. And that possibility is very important, because on substrate always we must give all of the nutrition on the water in all of the time. So if I have a high cation exchange capacity on my substrate, I can give alternating irrigation with complete nutrition solution and pure water. So that allows management the EC, for example. The biological properties, it should be noted that it's high content of lignin, 40%, and cellulose 35%, and low proportion of hemicellulose, because the hemicellulose is the fraction that is easily attacked by microorganisms. Regarding the microorganism, it's very important to know, when you use substrate, don't use microorganism in your nutrition. Okay, because the same microorganism that you have in the soil and make all of the composition of the organic matter will destroy, obviously, your substrate, and you will have a short life of your substrate, and you can have easily a plantation with more than 10 years of life, or 12. I don't know. I saw a plantation with 10 years without problem. Depending on its origin, the washing process suffered high C values. It's very important to wash very, very well. And when the EC value is saturated extract is higher than 1 or 1.5, you must to make other washing process, ideally using calcium nitrate, because the cocoa fiber has a lot of sodium, and with the calcium you can move the sodium. The concentration is between 500 to 1 kilogram per cubic meter to remove the salts from the substrate. And a quick way to verify if the coconut is saline or not is saturate a small amount of water, take a portion and drain it, and the EC, that drainage interest to be less than 1.5. Okay? Here you can see some plantations. Other important things obviously is the container. So the advantage of the coconut fiber has a high thermal inertia, high water retention power, greater durability, low apparent density, advantage in environment aspect because it's a subproduct from the coconut industry finally. So it's very important. Use always a good suppliers, a good distributor, because we have hundred, and the problem always is the quality of the substrate. And the container is very important too, because it's necessary to have a good drainage. And if you use a bag, it's very important to use a base to give a good drainage, not like this. This is a stone or something. The drainage is very bad. It's very important to use a base because the roots breathe, and the roots breathe 10 times that the higher part of the plant, the aerial part, when the plant doing photorespiration. And it's tremendously important for a shrub like blueberries because doesn't tolerate prolonged periods of anoxia, and because the blueberry is a calcifugus species and is affected by the formation of bicarbonate. And you can see in this formula, when I have water, H2O, plus CO2, we form H2CO3, that is carbonic acid, and release one proton, and the result is HCO3 is bicarbonate. So in the calcifugus species like blueberry, when I have bicarbonate or carbonate, the problem is interrupt the metabolism of the iron, and the plant can take the iron from the soil, but cannot metabolism the iron, and the plant very, very quickly turn yellow. And this is an example. This is the same substrate on the pot. We took the substrate from the bags and the plant in Mexico in a rainy season, and we put the plant and the substrate on a pot. And because the rain produced anoxia, finally the plant start to be yellow. All of the plants on the back drainage system, because the stones and the plant into the back, you can see hold the color, and it's very, very, very nice finally system to maintain a good drainage. Thank you.
Thank you, Sebastian. Now, Marius, you want to make some comments, questions?
Yeah. Hi, Sebastian. Hi, everyone. Sebastian, I have questions to you after your presentation. What substrate actually you see in countries what you're visiting in the, let's say, the biggest amount? What substrate is used? And the second question, to save the time, what is the common mistakes by the growers what you're visiting growing in the substrate? What actually mistakes can happen very easily in the substrate production?
The substrate that always I see in my visits, I have the lucky to work in a lot of countries in the 5 continents. And the most common substrate is the cocoa fiber. But be concerned that the substrate doesn't contain a high amount of long fiber. That is from a well-known and reputable supplier. Like I said, that is an inadequate washing treatment with calcium and not a potassium chloride. I've seen a lot of times the supplier use potassium to wash the substrate. It's more because it's more cheap. But then we have problems with the chloride and the sodium because the potassium has, one positive charge and calcium has two, and calcium is more strong finally to remove the sodium from the coil. The coil has a negative charge. And the second question, please.
Yes, Sebastian, the second question, the common mistakes actually in the substrate growing crops.
The common mistake, is the raw material. There are hundreds of suppliers. Many of them sell poor quality and poorly management substrate, even mixes compost, which shows very low technical knowledge on the part of the supplier themselves, because compost or all of the fragile substrate will destroy by the microorganism, and we need 5, 8, or more than 10 years of substrate. And also the management of the irrigation, so which you will talk about now, is tremendously important, since is the system there is no margin of error, since unlike the soil, the volume to retain water is very small. So if we commit a mistake with the irrigation, finally we will destroy the plantation.
Yeah. And Sebastian, one additional question. From your growers, when you're visiting all these continents, growers are using the already mixed substrate, or they trying to make them own?
No. They buy a ready mixed substrate. Okay. No. I saw the problem of when they mix it they own, but it's all in the major of the time they committed mistakes, and the final product is not good. But no, all of the growers they buy a ready substrate.
Okay, Sebastian, thanks a lot. Marius?
Yes.
The screen is all yours for your presentation.
Yes. I hope you can see it. Not yet. Yes. Yes, my presentation will be carry on a bit from Sebastian. I will be talking about differences between peat and coir growing blueberries. And first of all, I want to say thank you to all the organizers, Fernando, Sebastian, Gaston, for inviting me to this event. And I try to share with you my knowledge and experience over past years, mostly in Europe and Europe neighbor countries. Then let's start about a bit of substrate. The blueberry growers move into the substrate because have several advantages. Myself, when I was managing big farm, we moved to the substrate because we have problem with the pests and diseases from the soil. On the picture on the right, you can see actually plantation in center of Europe is Czech Republic, and actually we're growing here in the pots. It's not soil beds. It's soil beds only holding the pots. That means we have holes in the beds, and you can see the pots growing into these beds with good drainage. That means you can see actually it's very heavy soil. And to make sure the water is going out from the pots, the bottom of the pot is higher than the pathway to avoid any water come back to the pot what already was drained out. then yes, the growers are moving more and more to the pot growing because also want to have very nice and ideal condition for each plant. From my experience, always when we see plantation growing in the pot, if one pot is not performing well, we're trying to fix it or replace the plant or fix the irrigation, others. When we're growing in the soil, we quite often ignoring bad parts of the fields because not a lot we can do with that if we have pests or diseases or heavy soil or very sandy soil and water is going away. Then yeah, pot, like you see on this picture, the plants are looking like a soldiers. Every plant is the same, have the same amount of substrate, the same amount of roots and the same amount of water, what I will be talking in my next presentation. Obviously, I will show on some pictures and experience, mostly also from Poland. Then we can use, for the start, a higher density of pot-growing blueberries and spread them out during the next seasons where the plants are getting bigger to increase the acreage of the plantation and make the best spacing for the plants. We can't do that when we plant it in the soil. Obviously, like I told you, it's very key that in the pots, we will do everything to make healthy plants and healthy plantation and make sure that every pot and every plant in the pot is looking the same. Obviously, pot-growing blueberries allowed us to move pots around and also to change very quickly the varieties. If you want to change the varieties in the soil, it's more difficult because we have to change whole the field. Where in the pots, we can change part of the field, move the pots to another field or to another greenhouse or glass house. Advantage in Europe, mostly as a substrate in the past was used peat, white peat. The peat in Europe was quite cheap. I'm mostly coming from from Ireland and from Baltic countries like Lithuania, Latvia, and it was quite easy, accessible, and still is. To improve a bit of the condition of the peat, we use a lot bark. A lot of people was using wood chips, but that created the problems. But bark was quite often added to the potting blueberries when we grow in the peat. Now, these days, we're still growing in the peat, but is, let's say, improved physically by the coir and perlite. That means coir and perlite was added to the peat, and peat was good because it was keeping the pH under control. But now we're adding coir for better aeration and better water movement in the pots. Europe have, I think, the most experienced blueberry substrate companies, and they develop quite good substrate for blueberries. Most of the companies using this mix, and this mix is using a lot coir peat, what is always washed and buffered. Please don't use unwashed and unbuffered coir. We're using still white block peat mix, mostly from Ireland and Baltic countries. We're using short fiber mix. Sebastian mentioned about long hairs and all of that. We're using quite short fiber mix. It's depending how dense the peat is. And also we're helping with air and water movement with some percentage of perlite. Type of the substrate, obviously depending on your plantation. That means how long you want to grow in the substrate, pot size, water quality have big impact, what substrate you should use. Obviously climate, is cold climate, hot climate, very hot climate, or let's say climate, what we're calling as a mid climate, what is not with strong winters, but quite good summers. Then for blueberries, we're looking for very stable substrate. Like Sebastian mentioned before, we looking that some substrate can have very quick decomposition rate, what for long-growing crops like blueberries are, we not want to use. It's different in strawberries, it's different in raspberries, where we have short term, between 2 years, maximum 3 years, quite often in the glass houses 1 year. When blueberries, we're not changing substrate, we're not replanting every year. Then we need to use very stable substrate, what will be for many, many years good for our blueberry plants. Then you can see some substrate, what is really unstable and stable substrate. With blueberries, please use always more stable substrate and substrate what we can control. You can see the wood fiber, some green waste, black peat is not easy to control and is less stable, is unpredictable. Where the coir, when we're moving into the coir, and some white block peat, is quite often we on the edge here to have some control and to have knowledge already, quite high knowledge, how we can control the substrate. And the substrate have less decomposition rate than, for example, some green waste or black peat. Then I will talk a bit about fine tuning of nutrition. I think about nutrition, Sebastian is going to talk a lot in his last presentation, but I want to show you some differences between peat and coir growing substrate. Generally, peat, what we have from Baltic countries mostly, is very low pH. You can order these days peat with 3 pH, 4 pH, 5 pH, 6 pH also. And some limestone in the past was added to increase calcium availability in the peat. Obviously, the peat have quite good low EC, what is different than the coir. And we quite often was using mixed fertilizer with the peat to make some base after when we make the analysis. With coir, we have quite high pH. The natural pH of coir is around 6.8, what for blueberries is not the best. And that will reduce the manganese and iron availability, what I'm going to show on the next slide. The coir needs to be buffered to reduce the potassium and also the sodium. Then needs to be buffered mostly with calcium and obviously need to be washed like Sebastian mentioned. But we need to know also that new coir and coir, even after buffering, have quite high amount of boron. And boron for blueberries can be toxic. It's very, very narrow line between toxicity and not enough boron. That's what we need to control. That be aware that new coir always is high in boron, and when you're making the feed recipes, be aware of that. Used coir is already with less boron. Then moving into blueberries, yes, the coir is mostly and very happy use it. The companies producing the coir blends for blueberries more and more, let's say, with the product in every country. And obviously the coir produce better root development and more cost effective due to big saving on the transport because it's light, can be pressed. And these days, peat transport is more expensive than the coir transport. Chemically, coir, like we said, need a lot of work before planting, but the suppliers are doing all this work for us. We not have to be worried about that. That's why always use the good suppliers of the coir mix for blueberries instead to trying to make yourself. That is very, very important. I will move on because time is running out. Then I will show you some pictures of the pot-growing blueberries. This is this picture before COVID. It was February last year, where my friends from the company, Estefania Rodriguez and Abdelhadi Zougi from Morocco and Estefania from Spain, we visit Turkish growers. Turkey is the new blueberry country, is very, very rapidly expanding, just started about 5 years ago. And yeah, we exchanged the knowledge between Turkish growers from north, from south, and from Morocco. You can see the blueberry plantation on the high elevation. It's actually quite strong winter there. You can see the runoff station on the blueberry pods. I think Sebastian is going to talk about that also, and I about the irrigation also. High-tech tunnels. Actually, it's not tunnels, it's greenhouse. High-tech greenhouse with fans, with side venting, with screens, shading screens also. Then, yeah, it's getting big investment into blueberry growing in Turkey with very, very high-tech greenhouses for southern varieties also on close to the Mediterranean Sea. We start growing also pods in Emirates. You know the picture from Czech Republic in the pods. We start very successful growing in Bulgaria, And you can see quite good development in Bulgaria industry also, and pot growing is starting to be quite common also there, and they have also very, very, very hard winters. And you can see Poland, my home country. We starting, like I mentioned you before, with quite high density pots, where after that we spreading after 1 year, that they 1 year developing in the high density. There after winter, you can see the second picture, and after that we spreading to the tunnels, mostly to the tunnels and open fields under the hail nets. But yeah, it's quite successful. These pots in the middle have first harvest this year. That's how they develop in 1 year. And the picture on the right is new plantation, big plantation, middle of Poland, and everything is also in the pots and will be also partly put these pots in the soil, like in Czech Republic. Then very quickly, because time is running out, I want to show you differences. On the left-hand side, you can see soil growing crops, on the right, substrate growing pots, and you can see availability of each nutrition, and that is huge difference. When the soil on low pH, we have problem with phosphorus. Then you can see of substrate growing crops, mostly on the low pH. On higher pH, we have problem with iron and manganese availability. But unfortunately, in blueberries, we see a lot magnesium deficiency because of the low pH growing. Then that create a lot of problems to make sure the photosynthesis work properly. Very quick analysis of different varieties. You can see how low magnesium is actually in the leaf substrate. And from the water sources, we have very high boron. Actually, in some plants showed very hard toxicity. It's one plantation. We grow different varieties here. You can see some southern and also some northern, but it's still the same plantation. Then what we need to do for coir growing crops, mostly use other sources of iron than ADTA, because of the pH availability. And in manganese, not use only manganese sulfate, use also the chelates, like ADTA. And obviously, please buffer your coir, make sure it's buffered, and for the start, use extra calcium and magnesium. And on buffered, use even more, because if you know was not buffered, you need to use more of the cations. Also, for the start, coir needs less potassium than peat, because coir is already with high potassium, as is coming from the fruits. And obviously, use less boron, like I mentioned before. Some varieties already for the start need more iron and manganese. You can see differences in big numbers, even between the Blue Ribbon and Top Shelf. You can see close to 40-50% differences of amount of iron in the leaves, and they are the same fruiting season. Then already needs to be some work done about a lot of varieties, how the fine tuning of the feed recipes needs to be done, and obviously keep eye on the pH when you're growing in the coir. As natural pH of the coir is 6.8, and if you're not using a lot of your irrigation because it's cloudy, dark, for 1, 2, 3 days you not irrigate, your pH will rise in the pot in coir growing crops. Thank you. That's it.
Thanks a lot, Marius, for your very complete presentation. And Sebastian, it's your turn now to make questions to Marius.
Is growing in Europe?
Yes, in general, is bigger interest in the southern countries, where you can grow in coir quite easily, because you can, for example, in Turkey or Emirates or Morocco, the Mediterranean, very hot countries, we can use even 20 to 25 irrigation cycles per day in big pots, because, for example, in Turkey, you're using 45-liter pots to make sure that enough moisture is in the root zone. Then there is the coir, but also in Turkey, quite successful with the coir and peat mix, because of the hot climate and where less efficient irrigation systems. We're using this mix with the coir. But I'm very careful about pH in the coir. And in general, yes, it's more and more interest in the coir because of the availability from the major suppliers in Europe and also the transport cost. But yes, I quite kind of fan of the coir growing crops.
Okay, and you prefer peat or coir?
Thank you, Sebastian. In general, I quite happy with the mix, both of them. But I like to know how this peat and coir was treated before. Then the mix, both of them, is quite good. In different countries are using different mixes. For northern countries, it's more peat, less coir. But the percentage is like 50 to 40 and rest is perlite. But in the hotter countries, it's more coir and very little peat, but peat is more to stabilize the pH. But also the fraction, the suppliers in Europe, they know what fraction to use to make sure it's not only peat on the bottom and coir on the top. It's quite good mixes now in Europe for blueberries.
Perfect. And Marius, what do you think about the volume of the bag or the pot?
In general, I have discussion in the past about cost of the plantation, but I think in general, when I started, the 25-liter pots was enough, and we was thinking that will be maximum. But in hotter countries, I prefer to use a bit higher volume. We start in hotter countries with 45, but I think 35 is good enough. I not see bigger advantage go above 45 liters, but I have also growers what have 100 liters and 60-liter bags. But I think from around 35 in the hotter countries is okay. In the cooler countries, 35 is okay, and we see quite good development in 35. I think 25 is good if you can manage your plantation very well and you have efficient irrigation system.
Yeah,
but I prefer a bit higher.
I agree with you.
But if you not have good management of the irrigation and not enough, and your system is not enough, that means I will show on the next presentation how often we should come back with the irrigation cycles, then use the bigger volume because that reduces your mistakes on the irrigation. I found on about 35 liters now these days.
Okay.
I think if you asked me 3 years ago, I will be different answer, but it's developing.
Okay, thank you.
Okay, thanks a lot, Marius, Sebastian. Your turn again now.
Just one moment. Oh, let me try again. Okay, just please let me know if you can see my screen. Yes.
Marius?
Yes, can you hear me?
Yeah, Sebastian, turn now.
No, it's Marius.
Sorry,
Marius
go
turn.
ahead, Marius. Sorry, my mistake.
Okay, can you see my screen, please? Let me know.
Yes.
Okay, thank you. Then now carry on about substrate growing blueberries. And irrigation schedules are the most important for blueberry growing crops. And I think for all substrate growing crops, it's not only for blueberries. The key is that I think Sebastian gonna to mention that if you not manage your irrigation properly, then any fertilizer program, any changes in the fertilizer program never will work. Water is the most important part of the plants. Why? Also in blueberries and fruiting crops, water is used for a lot of things in blueberry plants, but look at that. 1% is used only for photosynthesis, 9% for growing, that means cell division, expansion, but 90% is needed for the transpiration. That means if the plant is taking water from the roots, is moving them through the canes, branches, and moving them to the leaves where the transpiration is happening and the water is going out from the plant. That is 90% of the usage of the plant. Without that, we not have development because by the transpiration, the plant is taking CO2, and that's how the photosynthesis can work. That means we need to keep going with irrigation to make sure the transpiration process is under control and is working. How we can do that, I will show you this picture. Don't look the numbers, please. Look the numbers only on the top and on the left-hand side in the column. That means on the left-hand side, you have humidity, relative humidity. On the top, you have temperature. You can see in this graph, where is the red color, is extreme high transpiration losses. That means the plant is using a lot of water to survive. On the blue region, on the bottom, on high humidity, you can see very low transpiration. We want to be in the green color. The numbers in the middle is humidity deficit in the grams, but it's not important now. Just to want to show you that on 30 degrees with low humidity, what most of the countries in hotter climate have, we have very high transpiration losses. That means we have to come back with irrigation a lot of times during the day, not overnight, during the day. A lot of advisors, a lot of us in the past, and also now, is more important also vapor pressure deficit. What we're using these figures to control the environment in the tunnels, in the greenhouses and glass houses. And it's similar. I'm not going to spend too much time on that, but it's similar. High temperature, low humidity create very high transpiration losses. If you not keep up with the watering, your plant will not produce good crop or not good quality crop. That means we need to make sure that we keep going with irrigation, and I'll show you in the next pictures how. Obviously, high humidity in the air will create blockage of the transpiration. Then you can overwet on overdoing the irrigation. That means it's good to make sure the management is going. I show you the pictures. The pictures is from actually 45-liter pot, and you can see how badly this irrigation was managed at the time, because was only wet part on the top and very dry on the bottom. That means we grow in 45-liter pots, but workable substrate was only about 20 to 30%. Then what you need to do, the pot and substrate growing crops, bags, substrate, in general, substrate growing crops, need more attention. And the attention will pay you always back. If you create a lot management and monitoring of your crop, irrigation crop, these plants will pay you back. That means you need to make sure that everything in the pot is working nicely to take the water. The substrate mostly is about from 45, what is already quite dry, to 70%. I measure the moisture in the pot always in the middle, because on the top you will see lower, on the bottom you will see saturation and quite high. That the middle is giving kind of average of the pot. But obviously the drainage is playing a big part, like Sebastian showed on his presentation. Then in substrate, we needed more often watering with short bursts, but every cycle, in my opinion, needed runoffs and drainage. That means we need to make sure we have good drainage. Obviously, on the fruiting time, we not want runoffs or drainage on the first 1 or 2 irrigation in the morning. But that is more detailed when we can go to that later. But in general, we want to make sure that every irrigation cycle have at least to 5 to 20% of the drainage to make sure we're taking the EC level, the unused nutrition from the water source or from the fertilizers, wash it out. That is very, very important. And that obviously the runoff level, the drainage level is depending on how good the water we have. If you have very nice, clean, let's say rainy water, yes, we not need a lot of runoffs. We're not putting extra sodium or chloride with the water. But obviously, we still need some runoffs, because if the plant is not using amount of sulfate what we're giving, then we need to wash it out. You can see the irrigation drippers. In general, you can see the example from Poland. For establishment, the growers start using the T-tapes on the top of the pots. I not advise this, but it's cheap solution for short period. But we need to know from this T-tape, one pot have 4 dripper points, another pot have 6, another have only 2. And sometimes they between the pots, the dripping points. That means each plant have different water amount. Don't do that, please, in the future. In general, we're using for pots over 10, 15 liters, we need to have at least 2 irrigation points, but over 10-15 liters, I required more, all to make sure to avoid dry and wet spots in the pots. Because if we not have that, in the pots what I showed you before, we find that limited growth of the plants where the irrigation not was managed properly or was blocked from different reasons. Then with only one dripper leads to poor moisture. Most of the investors quite often saying, why I need 4 dripping points? I can use only one, still plant will have water. No, we'll have water in only part of the pot, and the rest pot will be not working. Then we spend money on 30 liters of the substrate, and we will be growing only in small percentage of the substrate, and rest is wasted. Then general guidance for smaller pots, 7 to 15 liters, are using minimum 2 dripping points. Normally, I like even more. Larger pots, 25 to 35 liters, at least 4 dripping I using, and I always advising 4, because when I say to growers or investor use 4 drippers, you know what they're doing? They're doing 3 because it's cheaper. Then I always saying 1 more extra to make sure I have this number what I have. And the larger pots, we have some plantation with very large pots and bags. Yes, please use more than 4 dripping points. But that pictures, I'm not going to spend too much time about that, but it's also about runoffs and where the dripping point is actually in the position of the pot. On the left-hand side, you can see dry pot on the bottom because not was used enough length of the irrigation cycle. But on the right-hand side, you can see actually no roots on the top of the pot. Why? Because the stick of the point, of the dripping point, was too deep. And actually, we not have any moisture on the top, because it was about 8-10 centimeters below the surface of the substrate. Then we spent money on the substrate, we spent money on the pot, but we're growing only in 60% of the pot instead of the 100% of the pot. Then my friend, colleague from Turkey, grower, Halil, developed some irrigation for himself. I was grower, I was advisor. I always use this kind of spaghetti thing, what mostly came from the tomato industry to us. And after that to strawberries, after that to raspberries and blackberries. And we start using this also in blueberries. He said, Mariusz, these people always putting these dripping points in different places. I always will have dry place or always over a wet place. Then he developed from the same company, from the same parts, a ring. The ring have 4 dripping points, like the spaghetti one, but equally spaced, and always this ring was in the middle of the pot. After that, some industry irrigation companies developed the ring, also for blueberries, and this ring is also the pipe like my colleague is holding in the hands, but have 8 dripping points. That means you can see the industry also is going forward to make sure the distribution of the water in the pot is more equal, and every part of the pot have kind of similar moisture. Then it's always nice to see how that is dripping, because it's not leaking, because 2 liter pots per hour, it's like open tap. It's not dripping, it's leaking. Obviously, the points of below 1.5, 1.6, below 1.6 liter per hour, they start dripping. That means it's drip, drip, drip. And that's what we want from the irrigation. Then we mentioned containers, but I'm not going to spend much time. What it's about is good drainage. The best drainage, then better. I try to avoid side holes of the pot, because in the side holes always are growing weeds or algae, and actually the side holes doesn't work. They always block it. Then I avoid the side holes, like you see in the middle of the picture, is nice pot developed for blueberries. And the color, I always asking in hot countries if the people driving black cars. They're not. They're driving white cars because of the sun and heat. Then please don't use, if you can, black pots in the hot countries. Use different colors, because that helps. We tested different colors, and I want to say that any color was better than white or black. You have to be in the middle. White creating algae. If it's black inside, it's fine. Like bugs, for example, bugs are white, but they black inside to avoid the algae growing. But white pot will create the algae growing, and the development of the plant is not nice. I have to mention that. Irrigation schedules. Using the timer, most of the growers in the past, they not want to invest a lot in the blueberry irrigation. They're using timer. That means they put water 1 o'clock, 2 o'clock, 2 o'clock at night, and that's what they was doing for 1 hour. These days, to make sure the quality from new varieties of the fruits, the quality, especially in Europe, is rising. That means everything is about quality. Then without good irrigation, we're not going to make quality. We're not going to make shelf life also for the fruits. Then most of the watering needs to go during the day, very small amount in the morning and evening, and actually nothing in the night. I put 10% only for the hot countries because, for example, in Emirates or in Turkey, we have nights over 30 degrees. That means over 30 degrees Celsius, we have the nights. Then, yeah, we need to use extra irrigation because the transpiration still is happening. But when it's not so hot, we're not irrigating over the night. And most of the moisture in the pot is actually starting the irrigation in the morning after sunrise and finish before sunset. That means if you look in the pot, moisture is the highest, the hottest part of the day. And we're trying to lower, also to reduce a bit transpiration losses in the night, but it's a very small margin quite often, especially where we're fruiting. We're using also tensiometers. I'm not fan of it because it needs to be very good contact between tensiometer and the substrate. And they're not always perfect, but also industry developed quite good tensiometers now. But also we're using moisture probe. Then your setups about moisture can be used by the computer and they can trigger your irrigation to the pots. And you can see most of the irrigation, if you start doing this, is actually between 9 o'clock in the morning to about 4, 5 p.m. That means you can see that where the plant actually is using the water because proofs have showed us that actually very little is used early in the morning and later in the night. Where the transpiration is happening is always mostly in the day. Then Ratsum, I'm fan of the Ratsum irrigation schedules. The solar radiation is very, very closely correlated with the temperature and plant water use. Why I prefer this one? Obviously, proofs are good, but proofs need good contact, and quite often that contact is reduced when the plant is growing, and suddenly the irrigation can go wrong. But when we're using the solar radiation, it's very good. Why we start using? Because, for example, one day in Europe, we can have quite high radiation, what for Europe is quite high. For hotter countries, for example, in Turkey will be 2.5 joules, 2,500 joules. But let's say as an average, that is good, let's say September day or March day. Then, yeah, close to 2,000 is high radiation. You will see a lot transpiration losses, a lot water movement into the plant. But suddenly next day, we can have very low, cloudy day. Then we can't use the timer, okay? Then it's good to use the solar radiation for that because also that helps with this high transpiration water needs in the hotter parts of the day. And in the cooler parts of the day, the plant will use less water and the radiation obviously will reduce the irrigation cycles. Why are we doing this? Mostly because of the spring and autumn. In Europe, we have quite good summers. Last 3-4 years, too hot. Even in Poland was about 45 degrees. I just got back from Turkey, so I have to say it was holiday. But yeah, we have 48 degrees in the shadow. That is high. And we're growing blueberries there. And nights was over 32, 35 degrees. That means, yeah, blueberry did well, but they set up on the solar radiation. And I want to say that working perfectly in hot countries. And we not see any losses even on the 48 degrees in the shadow of the plants. The plants grow nicely, but yeah, it was 25 to 28 irrigation cycles in this computer, in these days. That's how computer put that in. That means, yeah, periods of the high light intensity, we see a lot dense irrigation. With low light intensity, can be cloudy, rainfalls, we're using less irrigation cycle. Computers using less irrigation cycles. We need to know that obviously computers have rest time what to set up. That means if suddenly it will be very dark, but plants needs water, the computer will put water. It's all about setups. Then, yes, give you a quick example because we can do watts, we can do joules, we can do lux. Then, yes, is some guidance sometimes how often the irrigation is going in minutes between each setups. That means if we set up, for example, on 200 joules, we can see how often on different light intensity the water can go. Then higher amount of light, you can see every 33 minutes on the 1000 watts per square meter will put the water. That means it's so important that the correlation between irrigation and solar radiation and plant water use is very close. And that, I think, is the best so far for what I'm using for past 15 years. The RAD-sum figures for irrigation schedules are most of the best, but you need to control your runoff level and adjust the computer setups every day. Thank you.
Thank you, Marius. Sebastian, any comments, questions?
Yes, I have a question for Marius. Marius, are the growers willing to spend money on more efficient irrigation with computers on Blueberry and Way?
Yes, in general, the new investments are pushing to make sure you're spending money once. Don't cut corners. It's famous English words. Don't cut corners. If you start cutting the corners, your production never will be correct. And you will spend more money to adjust the irrigation. Yes, the irrigation companies have more efficient irrigation systems these days. Most of the irrigation system coming from the glasshouse industry, they are the same. Not always we have to control the climate by the computer, but yeah, like you saw in Turkey, the development is going in high greenhouses, high-tech greenhouses where climate is also controlled by the same computer. And yes, the people, I think I have good experience actually in Turkey. The grower told me, I'm not going to spend money on irrigation. They need to manage irrigation. And they by fingers, they push one irrigation, second irrigation. 2 years, really, we not have crop. When I pushed to move to the computerized irrigation, suddenly was development of nice plants, fruits, and now this plantation is over 100 hectares. And all that because of the very efficient irrigation system. That means, yes, these days I will not advise without very good efficient irrigation system to plant blueberries. You need to have, because of the quality, before it was about volume, now it's about quality.
Of course. I want to say something about that, and we are in the ABO in Peru. For me, when I started to work in Peru at the beginning of 2010, it was amazing because the Peruvian they are making a very, very good job. The technology of the irrigation system, all of the controller are amazing. Really, really congratulations for my friends from Peru. It's a very, very good job.
Yeah, that's good. Great to hear, because obviously, like we know, Peru is quite young in the blueberry industry. That helps. But we in Europe, we have a lot of heritage. That means we have plantation over 10, 15, 20 years old. And it's so difficult to change in the mind of growers that, yeah, world is changing. Quality is changing, and density of the crop is changing, and the quality of the fruits is the most important these days. Then, yeah, it's now the irrigation companies in Europe are extremely busy. Sometimes you need to wait 6 months to anyone to come to you to do the costing. That's how the people moving into.
It's difficult to understand when the grower spent, I don't know, $150,000 per hectare in a substrate production, and then you go to the irrigation house, and it's a disaster. Maybe 1 or 2 tanks, 100 liters each, and then a venturi and nothing else. So it's very important that you said the controllers and the computers must to be with a good technology, good quality, because the irrigation is like our heart and all of our blood system inside us. So
yes, I always saying, these days also we have problem with water availability. That is, I think, coming in general to the world, especially now in Europe. Also, we see less and less let's say, water sources or good quality water sources. Then it's so important to make sure you find your water before you plant and make sure the water is good amount for your acreage to plant blueberries. And I always also saying, don't do to your plants what you will not do to yourself. Then
Obviously,
if you want
yes.
to drink, you drink. Then if the plant want to drink, have to have availability of the water. And I think it's good approach to the plants. They are alive, like we are alive. Then don't do to your plants what you will not do to yourself. I think that is the key message from the watering point of view.
Okay, thank you.
Thanks a lot. Very, very interesting exchanging of comments and experiences. Thanks a lot for the biblical reference. Marius, very good. Everybody understood very well what you mean. Sebastian, can we go ahead with your last presentation so we afterwards we can have questions and comments from the audience, please.
Okay, thank you, Fernando. So we must to be clear that through good irrigation, as Marius commented, with a good substrate, as Marius and I mentioned it, we must use a good fertilization plan to obtain quality fruit, which many times must withstand dozens of days on the road and then for sale, where most of the time the fruit is in a room temperature. Here you can see some problems with which fruit arrives collapsing. Is very, very common now to hear about the collapsing. Mold, soft fruit, rot. So the fruit that we send to the market will be consumed by demanding customers. They are very, very, they want to a very good fruit. Here, for example, is in New York, in Manhattan, the people stop to buy fruit in these heated carts and consider that fruit is eaten immediately. So if we don't sell a good quality fruit, finally we lose market, we lose consumer. Inside the supermarket, many times the fruit must withstand being sold at room temperature. You can see here this in the United States. Here you can see fruit, good quality fruit in South Africa. Good quality fruit in China. The Chinese, you know, they want a big fruit, a good bloom. The wax must to be a good quantity, a crunchy fruit with a good flavor. This is in New Zealand. Yes, this is in New Zealand. With a little bloom, it's not a nice fruit, and we must to consider that with the product that we put on the market, we must to make a promotion of the consumption. This is a good quality in Australia. Look, this fruit is in Zurich. It's not a nice bloom and bad appearance. It's in the central Paris, in the downtown, in a very, very fancy store, and you can see all the berries are in the room temperature. Here you can see the raspberries, the blackberries. This is the red currant, but a very nice quality fruit. Here you can see a good quality fruit in Germany, fruit without bloom in Finland, fruit with this is irregular quality in Holland. So finally, we must carry out the management at the best possible way, understanding that the plant needs macro and micronutrients in all of the cultivation stage, and we must to change just the concentration, but we need all of the macro and micronutrients in all of the stages of the plants. The hydroponic principle is the rational management of soilless cultivation implies a high knowledge, okay? And not only the physiological process and the mineral and hydric absorption, we need to know about the respiration, the photosynthesis, transpiration, like Marius said. So we must to provide a completely nutritive solution to the plant, and with a precise control according to each species, and in this case on the blueberries. In the phenological moment, with the climate characteristic to obtain the highest, obviously, profitability of the crop. And we must to control in according to the demand of the plant, with the proper chemical analysis, with a good substrate and a good control of all of the system. We must to know the root and the blueberries don't have radicular hair. It's just the new points of the roots that they take the nutrients from the solution. And we have in weathers with the 4 states on the year, with the autumn, with the winter, spring and summer, we have 2 peak in the root development. One is on spring, before the soil start to take temperature. The roots start to grow when the soil has more than 7 degrees, and then we have the peak between the 15 and 16 degrees. And then when we have 20 degrees and we have all of the development of the fruit, the development of the roots going down, and then in autumn, when the soil start to cooler, finally we obtain 15 to 16 degrees average. We have the second and the most important peak. And in the areas, the warm areas like Peru, like Morocco, like the north of South Africa, for example, Ecuador, we have just one peak after the pruning. After the pruning, we started to see a one big root development peak, and then go down when we have all of the fruit development. So obviously, I must to put the root development in all of the stage, because I need the new points to generate a good nutrition. And how I can manage the nutrition with the relation. So I can move the relation between nitrogen and potassium. The plant makes photosynthesis, and the photosynthesis create sugar bodies, and the sugar bodies go directly to form ATP. ATP is energy, and with the nitrogen form peptides, and then form amino acids, then peptids, polypeptids, and finally proteins. That means it's vegetative development. And with the potassium, all of the photosynthesis goes to metabolic routes to form carbohydrates, that mean reserve, and sugar. That is production. So if I make a relation between nitrogen and potassium, I have high relation is vegetative, high quantity of nitrogen and low quantity of potassium in molar concentration always. And if I have an average, is same quantity of nitrogen and potassium, this the name of compensated formula. Low is generative formula, is 0.5, for example, is a low quantity of nitrogen and high quantity of potassium, and very low is vegetative stock formula, is 0 to 0.25. That means, for example, when I start all of my vegetative growth, I need a high relation, high quantity of nitrogen, but low quantity of potassium. But always I must put the potassium, because the potassium, the plant needs the potassium for other process, not just for fruit. The plant needs the potassium to close and open the stomatas. The potassium can run more than 60 enzyme process, so it's very important. And when I want to fill the fruit with sugars, I go to the compensate relation with the same quantity of molar concentration of nitrogen and the same molar concentration of potassium. So I will have the vegetative development and sugar finally Brix degrees for my fruit, and the fruit needs proteins to grow. So I must use the same quantity of nitrogen and the same quantity of potassium. And when I have to start to make the change of color and increase the maturity of the fruit, I can go to a generative formula. That means a low quantity of nitrogen. Never use zero nitrogen, because the plants always need to form amino acids and proteins, and we use a high quantity of potassium to accumulate the carbohydrates and the sugars on the fruit. Sources: I can use nitrates, ammonium sulfate, MIP. Remember, there is a study from Spain in the 90s. There is a book, The Metabolism of Nitrogen. The two PhD in soil chemistry, they study the accumulation of the enzyme, the nitrate, the enzyme to allow the plant process and metabolize the nitrate. The plant can't take the nitrate from the soil when the nitrate is present. The reason that blueberry don't have this enzyme is because the plants grow naturally in acidic soils. So the plant is acidophilous species. The plant can tolerate the acidic soils, but doesn't mean it's the ideal pH to produce fruit. So the plant can take the nitrates if the nitrate is present on the solution and the plant start to make the enzyme and process the nitrates. It's a good way to control, for example, the acidification, because the ammonium release 4 protons when it goes to nitrates from ammonium. So for phosphorus, I can use phosphoric acid, MIP, monopotassium phosphate. For potassium, I can use sulfate, potassium chloride, but don't use more than 2 milliequivalents of chloride, because it will be toxic for the plant. For the calcium, always in fertigation, in hydroponic system, I must to maintain a relation with 2 milliequivalent of calcium and 1 milliequivalent of magnesium. Doesn't mean, for example, if my water have 4 milliequivalent of calcium, I must use 2 milliequivalent of magnesium, okay, to compensate the relation and maintain in order all of the cations. The magnesium is the same, and the micronutrients, always use mix of micronutrients in all of the irrigation, in all of the days, because the plant needs the macro and micronutrients in all of the days, all of the year. And for the pH, use 6. That means neutralizing the 75% of the bicarbonate in the irrigation water. You can use sulfuric or nitric acid. And if you use nitric acid, you must consider the nitrogen contribution. And you can use the sulfur burners, are very good to get a good pH. Here you can see this. These are typical figure that show us the availability of each element in a range of pH, and you can see if I go to between 4.5 or 5, or between 5 and 5.5 is the naturally pH of the blueberry in North America. I will have problem with the magnesium availability, with the calcium, sulfur, potassium, phosphorus, and nitrogen. So the range of pH, the ideal range of pH for fruit production is 6. In 6, I will have all of the elements in order and with a good availability for the plant. And remember, the problem of the blueberry is a calcifugus species. The the blueberry can't tolerate the bicarbonate or carbonate because interrupt the metabolism of the iron. But if you neutralize the bicarbonate on the water and you use pH 6, you will have a good production and a very nice plant. Acidification talk the sulfurous acid is very good because it's not dangerous if I compare with the sulfuric acid, and the advantage is release 2 protons. It's the same if I compare with the sulfuric acid. It's a very good system. I can use this system in organic production too. And be careful with the concentration of toxic element in the irrigation water. Here you have the information in ppm of aluminum and arsenic and all of the some trace elements that you can have on your water. Be careful with the electric conductivity, because I can have, for example, 0.8 millimos or decicement per meter. That is a good electric conductivity, but 1 milliequivalent, each milliequivalent give me 0.1 of electric conductivity. And I saw water, for example, with a 5 milliequivalent of chloride, that is toxic for the plant, the limit is 2, with 0.8 of electric conductivity. So when you take the water, you must send to make a complete analysis, because if I check just the electric conductivity, I can commit a big mistake and affect the plants. And when I make the mixes or all of the fertilizer, be careful with the antagonism. You can see here what happens. For example, if I put ammonium, I will have problem with the absorption of the potassium and the calcium or if I use phosphorus, for example, in mixed with calcium, or iron or zinc or copper. So be careful with the antagonism, and I can have synergies too, but it's very important to check this information. I don't know if you will have the presentation for you, but if you need the presentation, you can ask. I don't have problem to send the information. And how I can control the electric conductivity in my substrate. There is a rule that when I took the sample from the dripper and from the drainage, there is a rule always: the drainage must to have 50% more EC than the dripper. For example, if I have this situation with 1.46 EC on the dripper, the rule is I must to have the 1.5 more in my drainage. The half of 1.46 is 0.7. 0.7 plus 1.46 is 2.1. So I have 1.5. That means my drainage is too high. Okay, I'm leaching nutrients. So I must to adjust this and make more short pulses. And you can see in this example, the drainage is 45%. It's very, very high. So if I see more EC in my dripper than in my drainage, I must to increase the drainage. That's it, because I start to accumulate salt on my substrate. And remember, the rule is 50% more in the drainage than in the dripper. And obviously, in a blueberries, that the limit, if in the vegetative process, I don't want more than 1.2 of EC, and the plant don't have problem if I have less than 1.5, and the blueberry can tolerate 2.5. If I have more than 2.5, the plants will die. So between 1.5 and 2.5, I have problems. So I must increase my drainage if my EC is more than 1.5 to finally decrease the salt concentration on the substrate. Thank you.
Okay, thank you very much, Sebastian. We now go to questions from the audience. I have several questions of my own, but I will priority, of course, to the audience. Here goes the first one.
I don't know if Marius have question or not.
I think Sebastian have a lot of questions, but we have very little time. Then let's audience to question you and me.
Okay.
Okay, first question. About this, Sebastian, but which are the key macro and micronutrients that affect firmness, specifically firmness? Somebody from the audience is asking. Which are the macro and micronutrients that affect firmness, specifically firmness?
Yeah, okay. You can affect the firmness with, for example, with the ammonium, because the ammonium is metabolism directly into the plant and compete with the carbohydrates formation and the sugar formation. So when I put ammonium on the plant, I increase the vegetative development, and all of the photosynthesis body goes to the vegetative development and compete with the fruit. And the other thing is the ammonium has a positive charge and is an antagonism. Like antagonism with the calcium and with the potassium. So the ammonium is very important to control when I have in my fruit production stage.
Perfect. Any comments, Marius, on this subject?
Yes, I think it's good to say that when you analyze the nutrition in the fruits, harvested fruits, you will see differences between each harvest, even on the same variety. And the most hardened variety doesn't mean they have a lot of calcium, because by the growers, it's always the hardness of the fruits is related to calcium, and they always spraying with calcium and a lot of stuff. It's not actually. The most hardened fruits have less calcium in general when you analyze just fruits. But in the plant, it's more calcium in general, but not in the fruits. Then, yeah, I agree with Sebastian. It's not going to one or two nutrition. It's related between varieties, harvest period, and what harvest is. You always see less calcium, for example, in the last harvest, quite good in the first harvest. But yeah, it's a not simple answer and required a bit more talk and more explanation based on the analysis.
Yeah, and the ammonium effect negative is negative for the firmness, but like Marius said, the other, for example, a good nutrition with the bottom, with the potassium bottom, is the responsibility to move all of the carbohydrates inside the plant. The calcium give the shelf life. Finally, it's not the initial firmness. Is the shelf life the important thing with the calcium? But all of the nutrients, the macro and micronutrients, are important. So if you start to read about the nutrition, you can see all of the macro and macro and micro elements are connected, all of them. So if you have problem with one, you can affect all of the system.
It's balance.
Yeah.
Okay, thank you. Thanks a lot. Let's go to I think we have time for just one other question. And the question is as follows. What is the substrate degradation rate as time goes by, as time passes? And if that is the case, how would that compensation work in terms of managing that degradation?
I think, Sebastian, if you're okay, I will start.
Yeah.
It's quite important. The substrate decomposition and degradation is related to the moisture. then higher moisture and for longer time, the length of the moisture is giving very high rate of the decomposition. And that means nearly saturation of the substrate where the irrigation is finished, needs to be very carefully managed. That means we not want over wet substrate for long time. If will be for a long time, the decomposition rate is higher. And obviously that needs to be controlled. Then if the substrate pots acidic in the water, then you will see a lot of decomposition. And quite often you can see, even after 1 or 2 years, if the substrate, the pot or bags not have enough drainage holes and the drainage is not working, then you will see already a lot decomposition of the substrate on the bottom of the pot, what Sebastian actually showed on his presentation. Sebastian?
Yeah, Sebastian, we've got 1 minute left.
Yeah, I'm agree. You must to we must to take care finally the substrate with the irrigation, the oxygenation of the substrate, and remember, don't use microorganism in your fertigation. Organism, the beneficial microorganism destroy obviously the organic matter. So if you make a good management, I think the loss of substrate is very, very, very low. You cannot see.
Just to let you know, the oldest blueberry are already in the same 25-liter pots, and they already 18 years old. That means, and they well managed, and they still alive. That means. Yeah,
I work in plantation with 10 years old without problem, and nothing. All the substrate is same at the beginning.
Okay, well, this is, we don't have, unfortunately, more time. Thank you very, very much to speakers, to Sebastian and Marius, and to the audience, of course. I hand over now to Miguel.
Thank you, Fernando. Thank you, Marius. Thank you.
Thank you, pleasure.
Oh.
Thank you for everyone to make this happen.
Thank you, Marius, Sebastian, and Fernando, for this interesting discussion about substrate. Interesting to hear different points of view. I hope the audience has enjoyed this format. Now we're gonna take a quick 15-minute break before we go into our third presentation of the day, featuring Cord Brazelton and Colin Fain. So again, I invite you to visit the commercial area and see you back in 15 minutes at the stage.